Hey, what's up, guys? This is Chung here again. So let's take a look at number 116, populating the next right pointers in each node. This is like another classic tree problem. So basically, you're given like a perfect binary tree. So keep in mind, it's a perfect binary tree. So a perfect binary tree is every node has either two child or it doesn't have any child, right? And basically, where all the leaves are on the same level, and every parent has two children. So the binary tree has the following definitions. So besides the normal left and right pointers, we also have like a next pointer. And this problem is just asking us to populate this next pointer to its next right node. If there's no next right node, the next pointer should be set to 0, which means by default it's 0. There's a follow-up here, right? As you guys can see here, you may only use constant extra space. Recursive approach is fine. You may assume implicit stack space does not count as extra space for this problem. Okay. So, and here is a diagram examples here. Basically, as you guys can see, we have a perfect binary tree here, and we need to populate the next pointers. Basically, the one doesn't have any node on its left. That's why one's next pointer is none, and the next pointer is 3. Right? 3 is none. 4 points to 5. 5 points to 6. 6 points to 7. Yeah. So that's that. So there are like two ways you can solve this problem. The first one is what? If you guys watch closely, so this thing is like what? Just like the level traverse, right? So what we need to do is that we just use a queue and we do a level order traverse. And every time when we have like basically we'll record the previously node, and for all the nodes on the same levels, right? We always establish a link from the previous node to the current node. And that basically that's it. And to do that, we need to use like a queue to store all the nodes on the same level. So let's do that. Okay. So it should be pretty straightforward. Mm. So to do the level traverse, we need to create a queue here, right? So it's gonna be a DQ, right? So at the beginning, we have a root here, right? So it's gonna be a array here, root, and then while queue, right? I think it's always a good habit to check if not root, right? Then we simply return null. This is like the sanity check here. So here, while the queue is there, and we will do a level traverse. So the level traverse is what we just use like it. So the level traverse is just like the BFS, and we'll just do a for this in range length of the queue. Okay. And then we have a current. So the current one is the what? Q dot pop left, right? And then okay, I'll just write the level traverse template first, and then we'll add the other logic later on. And then if current left, right? Then we do a Q dot append append current left, right? So that's that. And then same thing for the right one. If current has a right node, we append the right node to the queue. Okay, so that's how we Yeah, so that's how we do the level traverse. And with this level traverse template, all we need to do is that with the current one, we just, like I said, we need to have like a previous one, right? The previous node. And then every time we have a current, we have a we have a pre previous one dot next equals current. But since we we initialize the previous node with a none here, we just need to do a simple check here. Basically, if the previous one is not empty, then we set the previous one's dot next equals to current, right? And then here we just update. Okay, okay, yeah. So that's that. And I think, do we need to return? Yeah, and then we just need to return the root in the end. Okay, so run the code. All right, cool. Accepted. Submit. Cool. So yeah, as you guys can see, so this is the first naive approach, not naive approach, but a very straightforward approach, right? Basically, we just use the level traverse, and then we for each of the current one, we just try to establish a link between the previous one and the current one on the same level. That's that. Okay. And as you guys can see here, we're using like a queue here. So we'll be storing the the same number of nodes with the last level, right? Because where it has the most nodes here. And here comes the follow-up. So you may only use a constant extra space. So how can we improve that without using the queue? Basically, we cannot use a level traverse. How can we build this? How can we build this next link here? So the way of doing it is that, basically we will build this next link from top down and from left to right. So the way it works is that, at the current level here, at the first level here, since we have the headers for this header, we know that, okay, we can build a link from the header's left to the header to this root's right. That's how we build it from the 2 to 3. Same thing for this 2 and 4 and 5. But how about this one, right? So to build the link for 4 to 5 is easy. We just use the current node, and then we build a link from left to right. But how about this one? How about the 5 to 6? So for this one, every time when we add 2 here, we will we will check if the current one has the next node. If it has one, it means that, okay, so we have a 2 to 3 here. Then we will build a link from what? From the headers from this current root's right to what? So basically, this one from the current root's right, GHT dot next current dot right dot next to what? To the current dot next dot left, right? Because so we do the current one dot next is 3, and 3's left is 6. That's how we build the link from 5 to 6, right? This is 5 and this is 6. And since we'll be building the links from top down and from the left to right, right? So every time when we're at the new levels here, the previous level's link or the next link have already been built. So from the current levels, we can safely use the previously level to build the current level. Okay, so for that one, let me try to explain a bit more while I'm implementing that. Okay, so like I said, so since we on each of the levels, we'll be starting from the leftmost node, right? Because we will start, for example, for this 2 here, we'll start from 2, and then we'll move to 3. And then for 3, we'll also build 6 and 7. If there's another one, we'll also move from 3 to another node, and then we'll build the child for that node. So that's why, I'm going to have like a leftmost node, right? At the beginning, the leftmost node is root. And then so the while loop is like this: while leftmost node has left. Okay. So it means that, if the current one, if the current one has a left node, it means that there's like another level down the road. Then we'll, we'll execute our logic here, and then we'll have like a head, right? So that basically the head will be the leftmost one. Will be like, for example, we are at 2 here, right? So the first, and then we will this head here, right? We will, actually, so and then we'll do I'll finish the outer loop here first. So the leftmost will be the leftmost dot left. So here basically we're moving to the next level, right? This is how we're moving to the next level. We're moving to the next levels, next the left one. We're moving from 1 to 2, from 2 to 4. That's how we update this leftmost node here. Okay, and so on the same levels, like I said, we'll be moving from the head to the head next, which means while the head is not empty, right? Then we do what? We do let's see. Okay, so at the current, let's say the head is here. It's 2 here. So the first link we'll be building is for 2 to 5, right? So which will be what? Which will be the head dot left dot next equals to the head dot right, right? So the first link. And how about the second link? So the second link will be what? Will be from 5 to 6. If the current head has a next, right? So it means that if head dot next is not empty, then the second link will be building is from this head's right, right? So this head dot right dot next equals to what? Equals to 3. How can we get to 3? Basically, it's the head dot next dot left, right? And then here will be, after that, we'll be moving the head to the head dot next, right? So which means that now we have built everything for both 4 and 5. Now let's move to 3 here. Let's move to 3 to build the link for 6 and 7. And if there's another node on the same level, after 3 here, we'll be moving that. So on and so forth. That's how we move this head, and how we move into the next level. Because like I said, because every time at the same levels, we'll build all the link for the next level, right? So that on the next levels we can utilize the we can use the utilize the links we have already built for that level, and then we populate then this levels, the next levels, next level. Okay, same thing, right? So in the end, we simply return the root here. Okay, run. All right, cool. Submit. Oops. All right. So okay, I forgot to do this sanity check here. Right. It's always good to check that. All right. So it's also accepted. And as you guys can see here, so for the second approach here, we're not using any of the we're not using any extra storage here. We simply just loop through the pointers from from top down, from top down by increasing by updating the leftmost node, and for the on the same levels we loop through from left to right by updating this head to its head to this head next, so that the space complexity will just simply be O1. All right. Um, cool. I think that's it. It is for this problem. Yeah, let me know what you guys think. And okay, I'll just stop here. Thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.